Hey guys, how's everyone doing? I guess welcome back. I guess we're going to start our next lesson. We're going to talk about one-to-one functions today. So for one-to-one functions, we have really, I guess we're going to combine it with the relation as well, because the relations are function, because they're set of there's set of elements for domain and range that are unique to each other, and we're going to find a one-to-one function. So the first thing we're going to do is we're going to define it. So one-to-one function. What that means is each element of the domain pairs exactly with one unique element of the range. And I'm going to spell unique. Perfect. Oh well. I did it again. Unique element of the range. So the first one we're going to look at is we're going to go ahead and look at a relation. So we have this relation right here. We have r is equal to -6, -1, -5, 4, -3, 5, -1, -7, 0, -4. Okay, so now we want to come up with the inverse of that. So come up with our inverse, and we just flip the elements for each domain and range. We're just going to flip them and change their orientation. So -1, -6, -5. Oh, no, that's not it. We're going to go 4, -5, 5, -3, -7, -1, and -4, 0. Oh, that's awful looking, but handwriting will eventually get better, I hope. So now we have our relation. So now we need to find out whether these is one-to-one. So we go back to what it means. Each element of the domain pairs exactly with one unique element of the range. So we're going to go through these, and we're going to define whether they're one-to-one. So the first thing to do that is we just need to establish if they're a function. Is R a function? Is R a function. So now we're just looking for repeating x values. I want to know if there's any x value that repeats itself in here. We have -6, -5, -3, -1, and 0. So nothing repeats. So the answer to that question is yes. So then I do it again. I do the same exact thing for the inverse. So is inverse relation a function? Okay. So we have -1. That's a 4. 5, -7, and -4. So there are nothing that repeats itself again. So the answer to that is also yes. So if the answer to both the relation or the inverse and the normal function, okay, if they're both yes, then we can establish that this is a one-to-one function. So we'll say, so R is a 1-to-1 function. Okay, so doing the relations is pretty simplistic. Okay, you just need to find the inverse. Now let's talk about right now, let's say, yeah, let's go a little further. Sorry about this. And let's go right there. Okay, so now we're strictly going to talk about functions. Okay, and let's talk about equations. Okay, so we have these two equations right here. We're going to talk about f of x first. So f of x is equal to 2x minus 6. If I wanted to find whether this is a one-to-one function, I would first need to be able to find its inverse. We haven't found out how to find inverses of equations yet, so we're going to do the graphing method. So right here we have 2x minus 6 graphed, as you can tell in this red line. So this is just f of x. Now, when it's graphed, I can apply two simple functions where the test is inverse is 1-to-1, or if this function is 1-to-1. The first test we apply is the vertical line test. So the vertical line test establishes whether 2x minus 6 is a function, because if it ever hits more than 2 points, then it doesn't work. Okay, so I'm going to draw my vertical lines, and at no point on this graph, on this f of x, will it ever hit two points on a single line. Okay, so that means this is a function, or it is a function for f of x. Now I want to apply the second test, and that one is the horizontal line test. Okay, and this one is for the inverse. Now, typically with the inverse, you do the same exact thing. You apply your vertical line test, but we don't know what the inverse is. But if we apply the horizontal line test, that'll do the exact same thing for us. So I apply the horizontal line test. And once again, it never hits more than 1 point per line. Right here, and so forth. So it does the same thing. So since both of these are correct, that means both the function and the inverse are both functions. Okay, they both work. So we'll say f of x is a 1, 2, 1 function. Now we're going to look at x minus 3 squared minus 1. So just a simple parabola. Okay. Looking at this, we do the same exact. Sorry, you can't really see that. Right there. So same thing. We're going to apply our vertical. And my voice does not like to do this today. My vertical and horizontal line test. If these both work, then it's a one-to-one function. So we apply our vertical. And perfect. Never does it cross more than 1 point for the vertical line test. So that's a check mark. Now we apply the horizontal. Ooh. Immediately I can see it hits more than 1 point at that line. So it hits 2 points. So that tells me the horizontal line test does not work. So if that is the case, we would then have to state g of x is not a 1, 2, 1 function. Okay? And that's about it. Okay? So if anyone needs to see, let's see if I can get the entire thing. I cannot. Perfect. We'll go over that right there. So this is one-to-one functions. Relatively simple concept, okay? Not anything I think too difficult. I think we've already kind of gone over this, okay? If you're not one of my students but you're enjoying these videos, okay, make sure you subscribe and follow. Leave a comment. If you need any questions or want me to go over anything for you, I can. I can go over how do I graph problems or stuff like that. Anything you need me to do. This is all it is today, guys. I hope you enjoy, and just make sure you're getting online. You're doing that kind of stuff. I know this video kind of rambled on about 8 minutes, and I do apologize. I'll try to keep them short in this, but sometimes they'll be a little long. Okay, it just kind of depends. But I thank you all for watching and tuning in, and just making the best out of this situation. Thank you.